Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Ladies and gentlemen, thank you for joining us today afternoon, 9th of July 2026. It's a great privilege to see this hall filled with distinguished guests and to be joined by many more participants to our online platform, reflecting the significance of this gathering. Bridging together academia, industry, and international expertise under one roof and connecting Indonesia, Japan, and Korea to the shared language of science and innovation. Welcome to the Global Innovation Talk, Bridging Academia and Industry, an event proudly presented by Study Program of Technology, Pulp and Paper, Institute of Technology Science Bandung, in collaboration with INA TAPI. Honorable Prof. Dr. Charmadi Mahbub, Director of Institute Technology Science Bandung, together with the University Leadership Team, Honorable Mr. Dr. Asep Yunta Dharma, STMT of Faculty of Professional Science Institute Technology Science Bandung, Honorable Dr. Edwin Sujabat, STMT, Chairman of the Indonesian Technical Association of the Pulp and Paper Industry, our distinguished visiting professor, Professor Hiroshi Ohi, PhD, from the University of Tsukuba, Japan, who is in person, and from Evelyn, PhD, from TPK Universitas Riau. We are also honored to welcome the Chairman of Japan TAPI, Mr. Terun Nobu Fukui. We are also delegated to welcome the representative of our esteemed sponsor and proudly industry partner who are joining us today, Mr. Hasan from PT Hasan Multilamesin, Mr. Eko and Mr. Guntur from Ethanol Buana Chemical Industry, Ms. Dania from APKI, Asosiasi Kop and Kertas Indonesia, Mr. Lim Kipung and Ms. Dewi from Bukit Muria Jaya, and Mr. Andre, Mr. Syahid, and Mr. Ardi from PT New Delhi Pulp and Paper Mills. My name is Arius Diana, and I will be your master of ceremony for today's event. And also all of you joining us today, our distinguished lecturers, researchers, students, and professional from the pulp and paper industry, whether you are with us here in the auditorium or participating virtually via Zoom meeting, we extend our warmest welcome. Today's event is funded as a simple yet powerful purpose to build a bridge between academia and industry for connecting our academic community with renowned expert in pulp and paper technology. Through an initiative to strengthen research collaboration, foster meaningful knowledge exchange, and inspire the next generation, in Innovator we will shape the future of the pulp and paper industry. This event also reflects our commitment to strengthening the quality of pulp and paper technology study program as we work toward achieving the highest accreditation status, Excellence 2028. We are especially pleased to welcome the many participants joining us from across the pulp and paper industry. Their presence today is a true statement to the strong partnership and we are fostering between academia and industry. Before we move on to the next session, I would like to kindly remind all participants to complete today's attendance by scanning to the QR code displayed on the screen at the front of the room. Okay. Next, before we proceed to the main program, please allow me to present today's agenda for the first opening, welcoming remarks, MOR signing, a presentation by our two distinguished professor, question and answer session, conclusion, closing, and photograph session. Ladies and gentlemen, please join us in warmly welcoming from Dr. Charmadi Mahbub, Rector of Institute Technology Science Bandung, as he delivers his welcoming remarks. From Dr. Charmadi Mahbub, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests, esteemed colleagues, honored guests and IDSB students, good afternoon and welcome to the Institute Technology Science Bandung. It is a profound privilege to stand before you today. We gather for the Global Innovation Talk, Bridging Academia and Industry. This event marks a significant milestone for our institution. We believe collaboration is the key to driving global progress. I extend our highest gratitude to Professor Hiroshi Ogi, PhD, from Tsukuba University, Japan. We are deeply honored by your presence and global perspective today. Your insight will undoubtedly inspire our faculty and students. International partnership like this will shape the future of higher education. I would like also to thank to Professor Ho Jin Park from GIU who joined online, I think, our university. Thank you, Professor, for bringing your valuable expertise to IDSB. I would like also to extend my gratitude to Dr. Edwin Sijabat, Chair of the NATAPI, and his team, which is also our faculty member here, who facilitate and make this talk happen. Our distinguished guest from University Rio, Professor Evelyn, Bapak dan Ibu dari BMJ, and then from Eber, from Indo Delhi, of course from Inatapi. Thank you very much for your support and attendance in this event today. Where I have forgotten your name, from Ina Japan. Okay. Thank you very much for your coming here. Ladies and gentlemen, today's event emphasizes the vital link between theory and practice. Academia provides the knowledge, while industry provides the real-world application. Together, we create impactful innovation for the global market. Following this talk, we will also conduct a crucial academic agenda. We will review the curriculum of pulp and paper processing technology study program. This program is also a cornerstone of IDSB in industrial alignment. Your expert feedback will help us elevate our educational standard. We aim to ensure our graduates remain highly competitive globally. To close my speech, I thank everyone who made this remarkable event possible. To Professor Park and Professor Owi, thank you very much for your guiding for you to guiding us. I wish you all a highly productive and inspiring session. Thank you very much and have a wonderful day. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. Dr. Charamani Mahbub, for your remarks. Next, it's our great honor to invite Dr. Edwin Sijabat, STMT, Chairman of INATAPI and lecturer in the Pulp and Paper Technology Program Studi Institut Teknologi Sains Bandung, to deliver his opening remarks. Dr. Edwin Sijabat, STMT, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. The Honorable Professor Hiroshi Oi, Professor Emeritus from Tsukuba University. The Honorable Professor Oh Jin Park from Jakarta Institute International University. Distinguished representative from IPSB, Pak Rektor, Pak Wakil Rektor, Pak Dekan, Bapak Ibu Kaprodi, Bapak Ibu dosen, and students of Institut Teknologi Sains Bandung. Representative from our sponsor, Pindo Deli, Eber Chemical, from Judy Harson, representative from industry, Bukit Nuril Jaya, from APKI, from Japan Tapi, representative from University Riau, UNRI, University of Buffalo, who joined online, and our partner universities. Our moderator, Ms. Rahmawati Apriani. Ladies and gentlemen, it is a great honor and pleasure to welcome all of you to the Global Innovation Talk, Bridging Academia and Industry, visiting Professor Series. First of all, let us give thanks to Almighty God for His abundant blessing, allowing us to gather today in good health and for this international academic forum. On behalf of INATAPI, Indonesian Pulp and Paper Technical Association, and the Pulp and Paper Processing Technology Study Program of Institut Teknologi Sains Bandung, I would like to extend my warmest welcome and deepest appreciation to our distinguished speaker and all participants who join us today. Today's theme, Bridging Academia and Industry, reflects a shared commitment to strengthening the connection between significant discovery and industrial practice. Sustainable innovation can only be achieved through meaningful collaboration that combine academic excellence, technological advancement, and real industry's need. As a university with strong partnership, particularly with Asia Pulp and Paper (APP) and broader pulp and paper industry, the TPP study program at IPSB remains committed to advancing education, applied research, and technological innovation. We believe the university should not only prepare future professionals, but also become driver of innovation that create tangible value for industry and society. Today, we are privileged to learn from two international respected scholars. Professor Hiroshi Oi will share his expertise on wood chip quality for craft cooking, while Professor Oh Jin Park, Professor Joshua, will present the commercial application of lignin from various biorefineries. The presentations are highly relevant as our industry continues its transformation towards sustainability and circularity and innovation. As chairman of INATAPI, I firmly believe that the future of our industry depends not only on investment in technology, but also on investment in people, research, partnership, and continuous learning. This event also serve as stepping stone toward the International Symposium on Wood Fiber Pulping Chemistry ESWPC 2027. Please show the flyer, which will take place from 4 to 10 July 2027 in Pekanbaru and Riau. On behalf of Inatapi and our organizing partners, I warmly invited all researchers, academic students, and industry professionals to join this international gathering as we exchange knowledge, showcase innovation, and strengthen global collaboration for a more sustainable forest product and biorefinery industry. I encourage every participant to actively engage in today's discussion. Every meaningful conversation has the potential to become tomorrow's innovation, and every connection can lead to impactful collaboration. We hope this global innovation talk will further strengthen international partnership, reinforce ITSB role as a hub for innovation and excellence in the pulp and paper sector. Finally, I would like to express my sincere appreciation to all distinguished speakers, sponsor, moderator, industry partner, the organizing committee, and all participants joining us both on-site and online via Zoom. Your presence reflects our shared commitment to advance knowledge and building stronger collaboration between academia and industry. I wish all of us a productive, insightful, and inspiring seminar today. Thank you very much. Domo arigato gozaimasu. Gamsamida. Enjoy the seminar and wish you a fruitful and inspiring discussion. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Edwin Sejabat STMT from your remarks. Ladies and gentlemen, we now come to one of the most significant moments of today's program, the signing of the MOA between Institute Technology Science Bandung and the University of Tsukuba, Japan, that is presented today by Professor Hiroshi Oi, PhD, to come to the signing ceremony. I will respectfully invite Dr. Asep Yuta Dharma STMT, Dean of Faculty of Vocational Education, Institute Technology Science Bandung, and Professor Hiroshi Oi, PhD, to come forward. Congratulations on this meaningful milestone and the beginning of a promising collaboration between our institution. Following the signing ceremony, we will proceed with the presentation of commemorative plaque as a token appreciation from Institute Teknologi Sains Bandung to Professor Hiroshi Ohi. We respectfully invite Professor Dr. Charmadi Mahbub, Rector of Institute Teknologi Sains Bandung, to present the commemorative plaque. Please come forward. Ladies and gentlemen, we will now move on to one of the highlights of today's program, the discussion session. This session will lead Mrs. Rahmawati Apriani, STMP. Before we begin next session, I will introduce the moderator who will be guiding our discussion. It's our great pleasure to welcome Mrs. Rahmawati Apriani, STMP, a distinguished lecturer of the Vocational Faculty of Institute Teknologi Sains Bandung, specializing in pulp and paper processing technology. Mrs. Rahmawati earned both her bachelor and master degrees in chemical engineering from Sriwijaya University. Throughout her academic career, she has actively conducted research in the field of pulp and paper technology, biomass utilization, environmental engineering, and sustainable waste treatment. She has led numerous research projects, serving as a co-editor of the journal Vokasi Technology Industry. In addition, she is certified environmental impact assessment assessor. Ladies and gentlemen, please join me in warmly welcoming our moderator, Mrs. Rahmawati Apriani, STMP. The time is yours.
Thank you for Mr. Adi as Master of Ceremony of this event. Assalamualaikum warahmatullahi wabarakatuh. Konnichiwa. Irasai as Professor Hiroshi Ohi and Mr. Terunobu Fukui from Japan Tapi. Annyeonghaseyo. Hwannyeong Professor Oh Jin Park from Jakarta International University. Good afternoon, Director of Institute Teknologi Sains Bandung, Professor Charmadi Mahbub, and then Vice Rector of Institute Teknologi Sains Bandung, Associate Professor Gunawan Wijaksono, PhD, Chairman of INATAPI, Professor Associate Professor Dr. Edwin Sijabat, Dean of Vocational Faculty, Dr. Asep Junta Dharma, Ibu Ajeng, as a head of pulp and paper technology, and also Prof. Evelyn from University of Riau, and my beloved students, employee and regular, and all of the ladies and gentlemen. First of all, I would like to say thanks for attending this event, Global Innovation Talk Bridging Academia and Industry, sponsored by INATAPI, Pindo Daily, Eber, and then PT Harson, and also Institute Teknologi Sains Bandung. We already have two great speakers, Professor Hiroshi Ohi. Let me introduce. He is Professor Emeritus from University of Tsukuba, Japan Tapi member, Overseas Technology Exchange Committee, representative of OE Consultant, These specification fields are wood chemistry, biorefinery of wood biomass, pulping and bleaching, chemistry, reaction mechanisms of carbohydrates and lignin, environmental chemistry, and he finished doctor course of Graduate School of Agriculture, the University of Tokyo, and then postdoctoral fellow at Institute of Paper Chemistry, Appleton Institute of Paper Science and Technology, Atlanta, USA. Doing many international activities as Secretary International Symposium on Wood Fiber and Pulping Chemistry in Tokyo, and Professor Oi will present the topic about quality of wood chips suitable for craft cooking. And we know wood is one of raw material for making pulp and paper, and one of the methods that used in industry is craft cooking. The raw material is fiber containing of cellulose and lignin, hemicellulose. Okay, for the details, ladies and gentlemen, I invite Prof. Oi to come to the stage to present, and your time 20 minutes. Time is yours.
Thank you for your kind introduction. So, I believe you should know the structure of xylan and cellulose, but from the fundamental chemistry, I would like to explain about what is xylan, what is cellulose. This is my topic. And secondly, I must explain about lignin, much more complicated structure than cellulose and xylan. Okay? Because, okay, first of all, pulp grade, what kind of wood is the most suitable? Do you know? For paper grade, generally speaking, I can say high ratio of xylan to cellulose ratio. Xylan ratio is higher, is better for paper grade pulp. But for dissolving pulp, for making rayon and cellulose acetate, for cigarette filter and other cellulose chemicals, so low ratio of xylan to cellulose is suitable. So what kind of wood species can we select? Should we select? Okay? From the fundamental chemistry, we need to learn more about what is xylan. Next slide. Yes? Next slide. Yes. Okay? So, how is the chemical structure of first D-xylose? D-xylose, which is D-xylose, 1 or 2? Do you know? Who? Okay? Raise your hand. You think one is xylose. Raise your hand. Or 2 is xylose. My answer is 1 is xylose. Okay? The second one. Next, please. Okay? So we must think about the mirror image of the carbohydrate. This is the basic of organic chemistry. Okay? Mirror means we have two kinds of organic compounds generally. Okay? Then next, please. Yes. So it has it has a chemical compound. It has 3 carbons. Okay, but it's not different from xylose. Xylose has 5 carbons. Okay, one by one, we can extend the structure of this chemical. Next, please. Okay, which is the xylose? Xylose has 5 carbons. You can see the second line. So, this is D-xylose, we call D-xylose. So, becoming complicated. So, next slide, please. Okay. But, so, there is 2 kinds of form. The one is furanose form. Okay, and the other one is the pyranose form. Okay, so in the case of xylose, mainly we have 2 kinds of form. The next, please. Yes. So, okay, now we know the anomaly of D-glucopyranose structure in the case of glucose. Okay, but most of them maybe studying engineer or chemical engineer, not chemist. So maybe most of you become confused and boring about this fundamental chemistry. But please study my materials. I already give you all of my materials. Okay, please study it in your home work. Especially young students must study about what is xylose and what is glucose as a first step, and then what is xylan and what is cellulose, the next step. And then we can understand, okay, reactivity of xylan and cellulose during the pulping chemical engineering process, and which good species is the best, we can understand. Okay, if you try to make a tissue paper or a paper board, xylan content is important. Okay, xylan cellulose ratio should be high. But if you want to get the cellulose chemicals, of course, xylan content should be low. And you can understand total pulp yields from the wood materials. In the industry, pulp yield is very important. If you reach, for example, 54, 55, more than 55 pulp yields based on wood weight, so we can get much more into, much more, how do I say, simply say, much more money, okay? And if the pulp mill, okay, pulp is lower than 40, then we lose money because pulp is higher is better, of course. And next, please. So, I shortly explain, generally speaking, so what is the difference of cellulose and amylose, or cellulose or amylose, or here for food materials, we have tapioca, for example, tapioca. Tapioca is made, the structure is made of glucose unit. The cellulose also made of glucose unit. But structure is completely different. Chemical structure is different. Okay? So this shows the anomaly of alpha anomaly and beta anomaly of glucose structure. Okay? So reactivity of the cellulose and amylose is completely different. Okay? And next slide, please. Yes, so you can see the beta D glucose structure. Beta is very important. Please remember, okay? beta structure. Beta structure is a simple unit of the cellulose. If you are producing, you produce paper mainly composed of cellulose, not amylose. If this beta D-glucose structure is different, if it is alpha beta structure, we cannot get cellulose. This is amylose. Okay, and glucose unit is D-glucose. Glucose has 6 carbons, but xylose has 5 carbons. Okay, fundamental structure is different. So xylose is one of the important unit of hemicellulose. Sometimes we use the word hemicellulose. So in the case of wood in Indonesia, tropical area, we call the wood divided into softwood and hardwood. The hardwood containing large amount of xylem. Okay, maybe you are using plantation hardwood. So please focus on xylem and cellulose. You may learn other hemicellulose structure when you use softwood, but in Indonesia, no softwood for pulp and paper material. Okay, you should learn first what is xylose and what is cellulose. Okay, the next please. Next is the most important one. We can skip this slide. Next. Okay, this is the xylem structure. Next, please. Yes, you can show this. This is data. This is data of the xylem cellulose or xylose glucose ratio. Okay. So we checked many kind of food species, but now today we like to skip this data. Okay. In the case of acacia, in the case of eucalypt, so xylem to cellulose ratio is varying. So you need to choose suitable wood species. If your target is paper grade pulp, okay, higher xylem ratio is better. Okay, if you try to produce the dissolving pulp for cellulose acetate or rayon or xylem ratio should be low. Okay. Next, please. Yes, this is a sample of the eucalyptus species from South Africa. In Indonesia, mainly eucalyptus now, eucalyptus perita, we are using perita. And we started to use many kind of hybrid species, eucalyptus hybrid species. And we also use acacia. In the field of peatland, you are planting Acacia mearensi. Or you can also use Acacia magnum. So from these species, you must choose which species suitable for making pulp. And then for teacher. And the next tables, figures. Excuse me, it's a lignin. Okay, I need to explain about the lignin structure. Okay. I explained about carbohydrate, cellulose and xylem, but lignin wood containing about 30% weight percent of lignin. What is lignin? Lignin is more complicated. Maybe you must study it your homework, okay, you can see these figures. What is lignin? And lignin unit is two types. One type is S-type lignin. The other type is G-type lignin. Okay? What is S? What is G? Next, please. Yes. So this is the lignin unit structure. But lignin is polymer. Okay, much more bigger. Next, please. Yes, more complicated structure. We need to learn about the structure of the lignin macromolecule, because we need to remove this lignin from the wood for making power more efficient. And for the chemical engineer, we can get data. Next, please. Yes, next, please. Okay, go ahead. Go ahead, man. Oh, finish? I don't think so. Sorry. Yes, this one. Okay, so how to remove lignin from wood species? Okay, so we need temperature and crack cooking liquor. And okay, so this is the delignification, removing lignin. This shows removing lignin ratio, velocity. Okay, so kappa number is a model of the lignin content. Okay. For the chemical engineer, we can get this kind of data, and then we know what kind of species best. Okay, so, but today I have a few minutes, so I already give you my materials, okay, please learn repeatedly, and finally, you can get easily to future of the fiber shape, fiber length and fiber width is very important for paper grade. And now we have a good equipment, laboratory equipment, and we can get many data. Next, please. The final. Next, please. Yes, so many data, but next, please. Next, yes, this is the data of the fiber shape. We can determine fiber length and cell wall thickness. We can gather these data. So in the laboratory, okay, and we compare this fiber length and width and other features of the too many kind of species. And for the tissue paper, which is better, for the paperboard, which is better, we can know which kind of species together we can know based on these fundamental data. So the young person must study and know so many things. So this is my suggestion. And one by one, and day by day, and shall we study together? Okay? And finally, please, final. Next, yes, maybe in October, please visit Japan. I like to show you the beautiful Mount Fuji, and I like to take you to some of Japanese paper mills to study together. Thank you for attention. I may shortly, so I have a lot of questions from you. Discussion is more fantastic.
Thank you for Prof. Oyi already present a great presentation, and all of the students already hear about the presentation. And I would like to add in some the resume. Mr. Oyi already explained about the quality of raw material of pulp and paper, and the content of chemicals like cellulose, lignin, and hemicellulose. He said xylan, or we call silan tadi ya, silan, and then the silan is can be used as the binder atau pengikat in paper industry, and then silan is also hemicellulose that must be removed in the pulp product. Okay, and then now we enter to the Q&A session, and please welcome the questions. The best participant from one of you who asked in the session will be given the merchandise, and please for the question. Okay, maybe first question maybe from me. Yeah, as a and translate. Okay. Ya, jadi tadi ada penjelasan terkait bahan kimia dari bahan baku kayu. Jadi ada jenis selulosa, kemudian hemiselulosa, lignin, kemudian beliau juga menjelaskan tentang struktur, mungkin dipelajari di kimia organik harusnya. Jadi jenis karbohidrat, ada selulosa, silos, kemudian ada amilosa, jenis-jenis karbohidrat, kemudian dijelaskan juga tentang bahan baku, ada eukaliptus, kemudian akasia manium sebagai bahan baku yang digunakan untuk pembuatan pulp dan kertas, dan beliau juga melakukan satu riset yang menjelaskan kandungan dari akasia, kemudian dari eukaliptus itu dari panjang seratnya. Kira-kira panjang serat akasia itu lebih panjang dibandingkan eukaliptus, sehingga harusnya lebih baik untuk pembuatan pulp dan produk kertas. Kemudian juga tadi dijelaskan ada tensile strength, jadi kekuatan tarik, jadi kekuatan kertas yang akan diproduksi itu dari akasia maupun eukaliptus. Itu dilakukan pengecekan, kita sebut sifat fisik dari kertas. Jadi ada beberapa sifat fisik yang dilakukan pengecekan, kemudian dibandingkan mana material raw material yang lebih baik untuk pembuatan pulp dan kertas. Nah, jadi mungkin dari Bapak Ibu yang sudah belajar harusnya dari 2025 itu sudah mendapatkan materi terkait ini hanya di disampaikan oleh Prof. Oi lebih detail lagi, gitu. Silahkan, ada yang mau ditanyakan? Oke. Yeah, Mr. Prof. always say that if you don't have any questions, I ask you the questions, the material from Prof. Owi. Yeah. Bahasa. Ya, jadi kalau misalnya nggak ada yang mau nanya, saya yang nanya nih. Jadi tentang materi yang dikasih Prof. Oi. Jadi tadi dijelaskan ada terkait yang namanya silan. Nah itu apa? Silan itu apa? Ada yang bisa jawab? Atau tadi kalau Prof. O itu sebutnya zairang, dia bilangnya ya. Kalau in Indonesia silan atau in English silan. Apa tuh? Kalau ada yang nyimak. Ya, silan. Ya, silan itu apa? Silan itu apa? Ada mic yang bisa ya Bapak. Oh, you want to ask?
Okay, thank you.
Mention the name and
sorry.
position.
Good afternoon. I'm Tohati from University Ramil. We create tissue paper. Tissue. Okay, I ask you about how that call silent and that satunya silent apa? Silent. What is that is name standard name or ditentukan sendiri gitu apa? Disebut silent sama ya silent sama zilan itu kenapa disebut silent sama zilan? Apakah itu nama tersebut? Oh silent. Oh Zailan. Oh oke. Kenapa itu disebut Zailan? Apakah nama tersebut ditentukan oleh peneliti? Apakah itu standar name dari sebuah struktur kimia? Thank you.
He asked, what is silent? What is Zairan? Yeah, and this is the question of me. And he asked again. Jadi tadi pertanyaannya itu yang ibu yang tanya. Jadi silan, ya. So silan is kind of hemicellulose, right? Jadi jenis hemiselulosa, Pak. Jadi itu namanya silan. Jadi salah satu. Ya. Jadi itu berbeda sama selulosa. Jadi kita kan punya selulosa, hemiselulosa, lignin. Nah, hemiselulosa itu salah satu jenisnya namanya silan, Pak. Jenis dari hemiselulosa. Next, maybe the next question. The next question.
I don't think so. Only one question, right?
Yeah.
We have at least 3 questions.
Okay, the next question. Next question. Is there any? Yeah, from Lukman.
Again, thank you. Good afternoon, Prof. My name is Lukman. I'm a student of Pulp and Paper Technology from ITSB. You explained higher SB ratio makes lignin easier to remove during craft cooking. However, is there an optimum SB ratio for pulp production, or a higher SB ratio always any disadvantage associated with an extremely high SB ratio? Thank you. Check about SB ratio. SB ratio.
Really good question. Yeah. I'd have to explain more. So, you know, okay, in Brazil, mainly we use Eucalyptus globulus. Okay, in the case of globulus, SZ ratio is really high, more than 5. Okay, and growing rate is very, very good. Okay, so globulus is the best food species in the world now. But second, okay, Perita is also good. But SZ ratio generally lower than globulus. In the case of Perita, 3 or something like that, in the range of 2 to 4. But globulus is 6, very, very high. And that means, okay, craft delignification rate efficiency is really good in the case of globulus. Perita is worse than globulus. Lower temperature and required less alkaline. This is efficiency. Okay.
Already answered, Lukman?
Enough.
Enough.
Thank you.
Yeah, understood. Yeah.
I like to discuss much more with him because the good question, almost the best question about the living, and his question is best question about the micellose and lignin is very important component of food. Okay, maybe near future, the new plantation may successfully plant to much better wood species, than Eucalyptus globulus. I hope so.
Okay, thank you. Okay, there is online question. Yeah, from Bambang from PT TEL. Thank you for your detailed explanation. I have one question. You have explained that pulp with high sealant to cellulose ratio, the strength of pulp or fiber will high too. How if pulp has sealant or xyram to cellulose ratio is high, but CWT of fiber is thick? High CWT fiber means fiber strength is low, which one will affect fiber strength silent cellulose ratio, or CWT of the fiber, pulp or fiber strength will high or low?
This is a question from website, right?
Yeah. From
It's very, very high level of a question. So could you show the this slide?
the characteristics of fiber shape. show the characteristic of fiber shape.
Yes. So you can see in this slide the fiber future. So fiber length or cell wall thickness, we can gather this kind of this.
Characteristic of fiber. And dua halaman terakhir. Lagi dua halaman terakhir ini. This one.
Yeah, you can see the fiber length and the cell wall thickness, fiber length and fiber width and cell wall thickness of each fiber. These data is average data. We can get these data from this machine, this equipment. Okay, this is also important information to chemical component of wood fibers. And these components are affected on paper pulp storage properties. Okay, so excuse me, could you explain his question again?
He asked about which one will affect fiber strength silang cellulose ratio or CWT of the fiber. Pulp or fiber strength will high or low.
From the standpoint of chemical component, okay, xylene ratio higher is better for pulp strength properties.
Xylene ratio
content ratio higher is better.
is better.
Better for pulp strength properties, especially, yes. But another factor is fiber future. Shape of the fiber, each fiber, length or width and cell wall thickness. So, in the case of acacia and the perita, eucalypt and acacia, each fiber shows us a different future, different length, width, and cell wall thickness. So, for a tissue paper or a paper board, we need to carefully choose which one is better. Okay? Maybe this question is, how do we say, is not the young student. I don't know.
Yeah.
Very good
They
question.
tell.
Very good question. Please send the award, okay, to website. Okay? Thank you for the good questions.
Thank you, Prof. Owi. And then the other question for online and offline. Is there any question? Yeah, from Sugan.
Okay, thank you. Good afternoon, Professor Ohai. My question is, why does the higher sale to Guaya Shield or SG ratio in lignin make hardwood chips easier to lignify during craft cooking and reduce the active alkali requirement? Thank you.
Yeah, the second question about lignin is very good question. It fundamental organic reaction chemistry reaction mechanism. So many researchers already showed the data using lignin model compounds of lignin linkage. Okay, lignin can be degraded more quickly if its structure is slim. Macromolecule, lignin is a macromolecule. Okay, so lignin has how do you say? Anyway, can we see the complicated lignin macromolecule? Yes, this one.
Please slide lignin structure. Lignin, struktur lignin.
Can you
Yang
see
kompleks.
structure? Structure?
Lagi,
No.
bukan?
No. Next. Go ahead.
Lignin struktur.
Lignin structure.
Struktur lignin.
Okay.
Bukan.
Go ahead. This is going back. Go ahead. You can see the unit of lignin structure first. Unit. Okay. Stop. Go back. Stop. One. Go back once. This is the unit of lignin structure. So S type has this methoxyl group. Okay. G is only one. Okay. G is only one. This function group. SK is 1, 2. Okay. This is the difference of S type and G type. Okay. So his question is, next slide please. Yeah, this is the macromolecule of these unit. So many D, S mixed structure, S and G, S and D. But, okay, if this is A and D's linkage can easily cut during alkaline cooking. But if we have a GG structure, like that GG structure, it's much more difficult to cut compared to S structure. Because this kind of reaction already clarified by young researchers. So SS linkage is most easily cut. Okay? And if S ratio is higher, in the case of globulus, it's easy to cut. And the macromolecule can be into small particles. I hope he could catch my answer. Anyway, later we like to talk more. Okay?
Ada lagi yang mau ditanyakan, Sugeng? Terkait struktur lignin? Ya, oke. Is there any question to Prof. Oi? Including the online. Yeah, 3 questions. Okay. Is there any question again? From employee, students maybe? 2025? Okay.
Selamat sore, Assalamualaikum warahmatullahi wabarakatuh. Saya Ferry Fardiansa dari APB 25. Ferry Fardiansa dari APB 25. Izin bertanya, tadi dijelaskan serat akasia lebih panjang dibanding serat eukaliptus. Dalam industri palet kan kita tahu NPKP lebih mahal atau untuk kosnya, Pak. Apakah bisa eukaliptus itu menggantikan NPKP? Apa aja syaratnya yang perlu dibutuhkan? Cukup sekian, terima kasih.
Okay, thank you. From Ferry, employee students, yeah, he said that in your explanation, acacia is have a higher length than eucalyptus, right? Higher length, higher length, yeah, right?
I cannot say generally. I think quality of acacia cactus is so-so. It depends on the target material.
No, I meant the length of the fiber acacia.
Uh,
The length.
What do you mean by rank? Excuse me.
What do you call it? Length. This one.
Length?
Yeah,
No?
the length of acacia higher than eucalyptus, right?
Length, yeah.
Yeah.
Okay, generally I think of course shorter than softwood. Okay, softwood pine softwood more than 3 millimeter. But in the case of acacia and eucalyptus, in the range of 1 to 3 millimeter. So distribution of this fiber length we can know, but I think it's not so large difference. But cell wall thickness is much more different between acacia and eucalyptus. So length is not so different. Yep.
But he said that acacia is hardwood, right?
Yes, hard.
Yeah,
Yep.
hardwood and has a high cost.
Hard cost.
High cost.
Acacia is high cost.
Yeah, but acacia, hardwood, and high cost, right? And BKP. And BKP is high cost.
NBKP is different from acacia and eucalyptus.
Yeah.
N is the pine and fir and from we export. And in Indonesia, mainly we import, right? NBKP or NUKP. Yes.
And he said that can be eucalyptus substitute NKP, right?
Okay. It's a very simple answer. Impossible.
Tak mungkin dia.
Why? So, okay, that means the fiber length is actually completely different. So, okay, NBKP fiber length is more than 3.5 average. Okay. So for usually we use NBKP for how do I say? But paperboard, right? In the case of paperboard, white paperboard, I think acacia BKP is good enough. We don't need not so high strength in the case of paperboard, whiteboard. But linerboard, for making a linerboard, we mix the two kinds of pulp, mainly recycled pulp. In this case, we need small amount of long fiber, still long fiber. Long fiber means NUKP, right? So that means we like to make a linerboard, strongness of the linerboard, and using recycled fibers, we need to put a small amount of softwood. This softwood cannot substitute by acacia. That's my meaning of my answer, impossible. But it depends on the pulp grade, paper grade. You understand? So, am I right?
Jadi jawabannya nggak mungkin ya Pak ya, eucalyptus digantikan oleh NBKP.
I'm sorry I have no time, so, and my English is not so good. So, and maybe if we have enough time, we like to discuss. Yes. I'm sure I will be here again.
Okay. Thank you, Prof. Oi. Maybe enough. The question, or is there any question again from participant? You will choose the best participant.
Selamat sore, perkenalkan saya Yusrianto Afrizal dari Lontar Pabrik Jambi. Saya ingin menanyakan berdasarkan dari tabel yang kita lihat di slide 26, di situ tertera ada data tensil, indeks dan burst index. Mengapa kekuatan mekanis akasia UKP secara konsisten jauh lebih tinggi daripada eukaliptus? Terima kasih.
Slide 26. Ya. Kekuatan indeks dari
Kekuatan mekanis dari akasia lebih tinggi dari eukaliptus.
Yeah, in the slide, you said that the strength of mechanical of acacia higher than eucalyptus, right? Yeah, why? Higher index. Why higher? Yeah.
So, in this case, as I said before, first Xylam ratio to cell ratio. But in this case, we need to consider about the fiber shape feature. So I show you the next data. Okay. So main please watch the density. Okay, acacia density. Acacia pulp density is higher than eucalyptus. Then density of eucalyptus in the range of 0.38, 0.47. But acacia OKP 0.44, 0.67 are higher than eucalyptus, acacia. Okay, and the next question is why density is higher, right? So it depends on the fiber shape. So we need to gather the next slide data. Next slide, you can see. Excuse me. This is the final amount. Anyway, very good question. Thank you.
Oke, jadi tergantung bentuk seratnya ya Pak ya. Makanya akasianya lebih tinggi daripada jenis eukaliptus. Oke. Okay. Is there any question from the participant? Maybe Prof. Oi can choose one of the best participant.
Of course, I cannot. Yeah, all of the question now. Very, very good question. Yes. We don't need to choose one of them. Please give me, okay?
Yeah. Okay, thank you for all participants who asked the questions. Maybe for the committee, we will give the merchandise for all. Thank you, Prof. Oi, already give the answer for discussion.
Sama-sama.
And thank you already give us a lot of knowledge, and maybe next we can learn more about the topic. Yeah, and Prof. Oi will have a flight today, and then have a good trip, and sayonara. Okay, now we continue to second speaker in Zoom platform. Prof. Oh Jin Park already entered the Zoom. And I would like to introduce Prof. Oh Jin Park. He is born in Bosung, South Korea. Nationality is Republic of Korea. Now he is Professor Mathematics Information Technology in Jakarta International University, GU, Academic Advisor LPPM at GU, founder Lignin Class, CEO and founder Tripling International or Education, Entrepreneurship, Bio-based Circular, and then economic. Doing a lot of researches, biomass derived sustainable functional carbon material, biorefineries renewable chemicals, industrial biotechnology, bio-based chemicals and fuels, applications of AI in education, and industrial biotechnology. He graduated his PhD in Korea Advanced Institute of Science and Technology Biochemical Engineering, doing a lot of experience like become Chief Technology Officers and Business Development. Professor Oh Jin Park will present the topic various commercial applications of lignin from different biorefineries. Biorefinery is a facility that uses biomass to produce bioenergy, chemicals, and other products. Lignin is chemical content that want to be removed from pulp and paper product. So lignin will become byproduct. Lignin will be used as biopolymer, bioethanol, biofuel, and also material cosmetic. Okay, ladies and gentlemen, for the details, we will hear the presentations from Prof. Oh Jin Park. 20 minutes time is yours.
Okay, thank you, Ibu Lakumawati. Thank you for this opportunity to share my experience with functional materials from trees today. And also I thank Professor Edwin for inviting me for this wonderful webinar. And also I'm glad to meet Professor Hiroshi Ohi from Japan. Hope to interact with you in the future. Okay, today for around 20 minutes, I want to share about the potential of lignins, the material of the future. So I'll introduce several commercial applications of lignins from different biorefineries. I'm teaching at Jakarta International University, and also I'm CEO of 3P Link International. On LinkedIn SNS, I'm also running Lignin Plus for networking with people involved in lignin research and commercialization. Okay, next slide. Right now the industry and the society is experiencing slow transition from carbon, slow transition from a material source from petroleum to renewable resources. So Nova Institute of Germany initiated the Renewable Carbon Initiative. So 3 carbon sources are from CO2 and then renewable carbon and waste carbon. So also United States, America Chemical Society recently published a paper, Green Chemical Initiative. These kinds of initiatives are emphasizing the transition of materials we use in everyday life and industrial materials from fossil resources to renewable resources. So this kind of materials not just to think about the source, but also the ultimate degradation. But today, we want to focus on just the natural source of our materials from renewable sources. Okay, next slide. Not just these kind of organizations, but industries moving faster than academics or these kind of organizations. For example, Continental, the German manufacturer of tires, they introduced green tires. So they put recycled material 17% in the tire, and also renewable raw materials like plant source around 35%. This kind of move is not just one company, but this kind of movement is spreading to all industries right now. Next slide. So what is biorefineries? The paper pulping is also one kind of biorefinery. So biorefinery is a facility that uses biomass to produce bioenergy, chemicals, and other products. So biorefineries are similar to petroleum refineries. We produce different kinds of products from the refineries. As you know, petroleum refineries are very efficient, so that almost all 100% of raw materials can be used for different products. So biorefineries are also targeting 100% of raw materials can be used in production of fuels and also materials. That's the biorefineries. Next slide. So let's talk about Indonesian situations. Indonesia announced Making Indonesia 4.0 to actively respond to the fourth industrial revolution and investing in large-scale system maintenance and R&D for ICT-based industrial technology development. But here, not only the ICT-based, but you can see here on the right-hand side, food and beverage and textile, apparel, automotive, and electronics, chemicals. These sectors are, requiring many different kinds of materials, but most of them are derived from petroleum sources. Next slide. So if you zoom in Indonesia, Indonesia is the richest country in terms of the amount of biomass produced annually. So Indonesia is the world's #1 biomass-related industry, but due to lackluster development of biomass industries, various environmental problems, economic sanctions are being imposed. For example, biomass are burned after harvesting of rice or the palm oil residues. So we can economically develop the processes to utilize these kinds of biomass to produce fuels and also functional materials from palm oil and then rice, coconut, sugarcane, cassava, and also trees. So from these plants, we can produce different kinds of waste materials. If we use these waste materials for functional materials, then we can increase the value of the rural economy, and also we can reduce the impact of the burning of these waste materials. Next slide. For example, Kelapa Sawit, the palm oil biorefinery, produces the first main product is oil. for cooking and also other industrial chemicals. But not just this kind of oil. Next slide. We produce from kelapa sawit, we also produce empty fruit punch. Right now, I understand most of this kelapa sawit empty fruit punch is used for pupuk, fertilizer for plants. But yeah, it is good use, but also we can divest the use of this biomass in other applications. Next slide. So globally, industries are working to produce different materials from biomass, plant biomass. For example, Stora Enso Finland company is producing cellulose from conventional pulp mills. And there are other pulp mills, but there are second generation cellulosic biorefinery from wheat straw. For example, Clariant, a German company, they started operation their second generation cellulosic biorefinery for producing bioethanol in Romania. And there are other Indian companies and also Brazil companies which try to produce bioethanol from waste lignocellulose. Next slide. For example, Raisin is a Brazilian company. From sugarcane, they produce bioethanol, but from bioethanol is produced from cellulose materials. When cellulose is degraded to produce glucose, which can be converted to bioethanol. But still, there are 30% of lignin waste material from the sugarcane biorefinery. So they team up with the Valtero company to produce lignin derived biofuel. Next slide. And depending on the extraction processes of materials from biorefinery, we can produce different materials. For example, these three examples, Origin and UPM Biochemicals and Fulton Bio2X, demonstrated that using different extraction processes, we can produce different products. So Origin materials produce the terephthalic acid, the material, one of the monomers used in the bottles. And also UPM produce ethylene glycol and also RFF. I'll show you later what is RFF. And then Finnish company Fortum use different processes for extraction. They use organosolved lignin to produce furfural and acetic acid and also lignin. Next slide. So from the same raw materials, for example, trees composed of 30% lignin, 50% cellulose, 20% hemicellulose. For pulp mills, we use only 50% of the biomass in the trees. But there are different biorefinery companies. They are producing different products from the trees. So at the bottom, Origin and UPM, Lignin Industries and Fibonol, those companies are producing not cellulose, but different products from trees. Next slide. So yeah, I understand there are students who are studying pulp and papers. I understand you already learn a lot about cellulose and pulp, but yeah, lignin is produced in pulp mills as well, but usually they are burned for energy purpose for pulp mills. So the lignin is aromatic materials, three-dimensional amorphous aromatic polymer. So it's a natural glue in the fiber, and then only 1 to 2% are used in value-added products. So as I said, majority is burned as fuel. Next slide. So I worked before I came here to Indonesia. I worked in a startup company in Korea. The name is Lignum. The Lignum biorefinery process is different from UPM and also Fibenol. They use acid treatment for partial hydrolysis of cellulose. And then during the process, lignin is condensed, and then lignin is produced as the major material in the biorefinery. So they are commercializing the lignin material. Lignin is not byproduct from this biorefinery. It is the main material. So we can say that first come, first served. We can find the application of this lignin. This lignin is different from craft lignin from conventional pulp mills. So we have to find the application because nobody tried this kind of lignin in the industrial applications. So I want to share a little bit of the product development. I was involved in the company. Okay, next slide. Yeah, so this is the same image of safe, sustainable, safe, environment-friendly, innovative filler. So here, the lignin produced in this process contains microfibril cellulose as well. So this lignin is different from other lignins. So here you can see the fibers and also the lignin materials. Next slide. So we can add the safe in different applications, but to get approval from biomass derived materials, we underwent the approval process from America Department of Energy biomass certification. And compared to other fillers, this organic filler is lightweight and then toxic free because it is organic, and also this filler does not pollute the nature because the conventional fillers like talc derived from mines, so safe filler is not polluting. Next slide. Okay, so the first application of our safe filler is in the car parts, automotive parts. So we put our filler in the car parts, door trims and tailgate of the commercial vehicles so that the car parts can be lighter than car parts using talc, inorganic fillers. Next slide. And this kind of success can apply to other brands. So we tested with other commercial automotive parts. And also our safe filler can be mixed with biodegradable polymers like PLA so that we can use the fillers in 3D printing filament. Next slide. And another benefit of this safe filler derived from lignin is lightweight. So if the vehicles become lightweight, then we can save energy. So while running in the lifetime of the vehicle, we can save a lot of energy that leads to the reduction of CO2 emission. Next slide. Yeah, this is the simplified diagram of the extraction process and the final products from trees using lignum's proprietary process. Next slide. And lignin from other companies like UPM Biochemicals used in rubber products as well. So RFF, renewable functional fillers. These fillers are different from lignum's safe filler because the extraction process is different. So lignin can replace carbon black for ethylene propylene diene monomer in the automotive weather strip to preventing the penetration of water in the vehicles. So in this case, more than 90% of carbon reduction and lightweight compared to carbon black. Next slide. And also Finnish tires, Nokia tires, they developed Green Step Ligna concept tire. So they use lignin from Fibhenol company, and then they this kind of replacement represent a concrete step towards more sustainable transport. Next slide. Yeah. So as I said in the beginning, like a petroleum biorefinery, if in biorefinery also from the raw material to the product. So every part of trees should be utilized for products, not just the cellulose, but also lignin. So in this slide, lignin industries, they are using many different kinds of lignins from different biorefineries, even pulp mills. They use craft lignin to put in their process to produce renol, which can be integrated in the everyday goods so that we can make the product more circular. Next slide. And usually the lignins produced from biorefineries are black, not black, the brown color, but recently a Swiss company, Bloom Biorenewables, they use aldehyde-assisted fractionation technology to produce white lignins. So because the lignins are different, so we can use this material in cosmetics and more value-added applications. Next slide. Yeah, this slide shows that the lignin industries, they are using renol, which contains different lignins from different biorefineries. They tested different kinds of lignins from different sources. This slide shows that after some test, we can see which kind of lignin is best for each application. So as we get lignins, more lignins, different kinds of lignins, you can see more applications of lignins in industrial applications. Next slide. Okay, this is my presentation. If you have any questions, yeah, you're very welcome. Okay.
From Joshua.
Any question from the audience or?
Oh yeah, please.
Good afternoon, Professor
Okay.
Jimpa. My name is Leah. I am from Palm Oil Processing Technology. I want to ask about what is the advantage to produce SSEIF from lignin, and what is the impact on the environment? Thank you.
Okay. The advantage of sustainable and safe environmental friendly innovation filler, we call safe biofiller. It is using sawdust. When you process trees, you can generate sawdust. So sawdust has applications in other applications, but sawdust is produced in sawmills. So we can use actually raw materials, waste raw materials. So we are using waste raw materials for the process. Another advantage is that SAFE finds different applications in not just the car parts and also rubbers and also lubricant applications. And so these kind of applications was not developed before with lignins from other sources like a Kraft lignin. And also the safe filler derived from Lignum's biorefinery is odor-free. Kraft lignin has sulfur. Kraft lignin usually contains sulfur, but Lignum's safe filler is odor-free. That means we can use that for interior parts. So that's why we tried in automotive interior parts like door trims and tailgates. These are the some of advantages of safe biofiller. Okay, thank you. Okay, there is a.
Thank you for Ms. Leah and Prof. Ojimpa. And next question. Is there next question?
I can see here, I have a question from Bambang from PTTEL. Thank you, Professor Park, for valuable knowledge. Are there any quality requirements that need to be met for lignin to be turned into a value-added product? Because the lignin produced from the Kraft process contains, yes, high sulfur. And how to reduce sulfur from Kraft lignin? I'm not an expert in desulfurization of Kraft lignin, but it adds cost for Kraft lignin to desulfurize. But there are other applications of Kraft lignins. They can be used in road pavement, like asphalt. They can replace asphalt for road pavement. And also Kraft lignin can also be used in adhesive for wood panel. So yeah, even Kraft lignin, there are lots of applications. And then, yeah, a lot of research is going on to make money from Kraft lignins. So yeah, there are many reviews about lignin applications of Kraft lignin. So yeah, if you send me email, I can share the reviews, and then we can talk more about the commercial potential applications of Kraft lignin even in Indonesia. So I know several groups working on lignins in Indonesian academic community. So yeah, thank you for the question, Mr. Bambang.
Oh Jin Park.
Hello? Hello, I'm here.
Tadi dijelaskan tentang aplikasi ya. Jadi aplikasi dari lignin jadi bisa dimanfaatkan untuk sebagai biochemicals, kemudian ada juga bioetanol, kemudian bisa dimanfaatkan untuk material kosmetik. Jadi aplikasi lignin yang berasal dari raw material kayu. Jadi sebagai byproduct atau hasil samping dari proses pulp dan kertas. Jadi Prof. Oh Jin Park memiliki beberapa research untuk mengembangkan penggunaan lignin ini secara komersial. Kemudian bisa sebagai aditif dari baterai aditif.
Yes, yeah.
Ada yang mau ditanyakan terkait ini?
Yeah, so lignin also can be used in battery as another material. So Stora Enso also tried this opportunity, and then other companies also try to use lignin as graphene, another carbon materials. So we'll see more developments from lignins, but right now graphite is the main another material in battery, but in the future we can see lignins in the as a carbon materials in the battery applications. That's what I expect. Thank you.
Untuk karbon material, jadi sedang dikembangkan. Oke, ada yang mau ditanyakan terkait aplikasi yang sedang dikembangkan? Silahkan. Oke, ya, Miss Ajeng.
Okay, good afternoon, Prof. Joshua. My name Ajeng from Pulp and Paper Technology Process. Sedikit cerita, I have one research about lignocellulose. I get lignocellulose from extraksi acacia, and then result of lignocellulose applied to dry strain in brown paper. I have problem about color of lignin. If we application lignocellulose to white paper, I cannot remove the color brown color from lignocellulose. Can you give me a solution how to remove the color of lignin? Thank you.
Okay, thank you, Ibu. Yeah, is the final application the purpose of extraction is getting cellulose or lignin? Can I ask you one more time? So the final goal of your extraction is to get cellulose, or what is the final product for your extraction process?
Yeah, my final product is lignocellulose. Lignocellulose combined with some chemical to fabricate dry strain in brown paper. But we have problem in color from lignocellulose. Can you give me solution from for remove the color?
Okay, yeah, I'm not a paper chemist, but yeah, the extraction process, I don't know what is the extraction process, but as far as I know, even in paper making, to produce white color paper, they are going through bleaching process to remove color of lignins. So, yeah, depending on the extraction process, depending on the final product you are targeting, yeah, you have to think about the color issue. But in the case of Bloom Bio Renewables, the target is white lignin. So they use the different extraction process, aldehyde assist fractionation. So yeah, it's a long-standing process of craft pulping. So depending on the extraction process, we can get different lignins and different products. Sometimes the cellulose can be degraded or cellulose can be converted to other biochemicals. So depending on the demand and also applications, yeah, it's not easy to develop a commercial process, but yeah, you have to systematically what is the demand of the biochemicals from biorefineries. At the moment, that's what I can say.
Ditambahkan bahan kimia ya, kemudian untuk lanjutannya menggunakan proses bleaching ya, dijelaskan Prof. Joshua. Okay, is there any question? Okay, if enough, Prof. Joshua can choose who is the best participant who asked, from Bu Lia and then Bu Nurul Ajeng and then also in online, right?
The Bambang, the question from Bambang, from PTTEL, I can choose the question as the best question from my side. But thank you for every question.
Okay. At these seminars, and also thank you for all participants already asked in this session, and we already hear about two great speakers. Let me make some conclusions. The first from Prof. Oi Sensei. He already explained about the chemical contents of fiber are cellulose and lignin, and cellulose is a polymer of glucose, lignin is a polymer of serine type and D type monomer, glucose is simple carbohydrate, and we already hear about the structure of type of carbohydrate, the difference in fiber shape affect the difference in pulp strength. As example, for raw material, acacia and eucalyptus as raw material, which has length of acacia is higher than eucalyptus, and fiber width of acacia is lower than eucalyptus, and we can choose the best material from the raw material to making pulp and paper from the physical properties, and then comparisons of the strength properties between acacia and eucalyptus before enzymatic treatment, like tensile index acacia higher than eucalyptus, pulp brightness of acacia lower than eucalyptus. And also from Origin Park we got some lessons, like 5 sectors were selected for making Indonesian 4.0, like food, beverage, textile and apparel, automotive, electricals, electronics, chemicals, and Indonesia has the world's #1 of biomass-related industry. The example of biomass like rye and sugarcane and palm kernel cell, coconut cell, wood waste, and then straw. But the reckless development of biomass industry, various environmental problems and economic sanctions are being imposed. So our duty as Indonesian people to utilize the abundance of biomass and fix all of the problems that happens. I think that's all for me as moderator. I apologize if there is a mistake. Thanks for your attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. I give back the time to MC.
Okay, thank you very much, Mr. Rahman, for the STMT for guiding the session. We hope that the knowledge we have gained today will be beneficial and important our insight. So before we conclude, would Professor Hiroshi Oi like to share any final remarks? Please. Okay, maybe probably Hiroshi have the problem, guys. Okay, ladies and gentlemen, without further ado, we have now come to the end of today's program. On behalf of the organizing committee, we would like to express our deepest appreciation and sincere gratitude to our distinguished speaker, honorable guests, participant, and all members of the organizing committee for your presence, active participation, and invaluable support, and all which have contributed to the success of today's agenda. We certainly hope that this program has further strengthened the partnership between academia and industry, while opening new opportunities for broader and more sustainable collaboration in the years to come. I'm Arus Diana. It has been our great honor to privilege to serve as the Master of Ceremony For today's event, we sincerely apologize for any shortcoming or mistake we may have made while hosting the program. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih. Oke, untuk Bapak dan Ibu yang ada di depan, boleh untuk maju ke depan, ada penyerahan souvenir yang kami berikan sebagai kenang-kenangan untuk Bapak dan Ibu semuanya. Monggo dari Bapak Dekan mungkin ya, untuk dibantu maju ke depan.
Wajah.
Oke, mungkin sudah bisa ya untuk teman-teman boleh naik ke atas panggung di dibuat barisan. Ayo teman-teman semuanya untuk naik ke atas panggung, mungkin diikuti juga oleh Bapak dan Ibu dosennya. Nanti Bapak dan Ibu dosen berada di tengah dan untuk teman-teman berada di samping dan di belakang ya. Ayo teman-teman panitia juga pada naik ke atas ya, semuanya ya. Oke, boleh teman-teman dibagi jadi 3 barisan ke belakang kali ya, jadi biar nggak terlalu panjang. Jadi teman-teman bisa kelihatan. Yang di depan mungkin boleh gaya apa tuh namanya kalau kalian main bola, futsal setengah. Nah, gitu cakep. Oke, ngantuk, lapar, sabar. Oke, teman-teman. Nah, yang di pojok sebelah sana juga agak rapat aja. Jangan pada mundur-mundur banget. Nah, ayo. Yang sebelah sana juga sama. Oke, kita bikin 3 baris ya teman-teman. Yang merasa tinggi paling belakang. Yang paling merasa tinggi paling belakang. Jadi gini urutannya, kalian bikin 3, 1, 2, 3. Nanti Bapak dan Ibu dosennya di depan. Ya, ayo diatur. Bikin 3 barisan. Yang tinggi di belakang. Campur aja, nggak apa-apa. Ayo. Ya. Nah, yang sebelah pojok kiri sama kanan nanti agak dempet ya supaya dapat ininya. Dempetin aja. Enggak. Bu Amel mungkin Pak Hizmi. Tunggu ya, kita tunggu Bu Amel sama Pak Hizmi dulu teman-teman ya. Oh ini dulu. Foto dulu dulu. Kayak gitu. Oke ya, kita mulai ya. Ada di sini semuanya. Aku hitung 1 sampai 3. Kita mulai fotonya. 1, 2, 3. Oke, ganti gaya. 1, 2, 3. Oke, bebas. 1, 2, 3. Ada tagline nggak Bu?
kita bikin video. Ya, Cok.
Kalau saya bilang selagi pas, yang lain jawab.
Satu, dua, tiga.
Solidify integrity, attitude, ability.